Welcome to the Trimos Experience Center, home to some of the finest and highest precision Swiss dimensional metrology equipment you can find on shop floors all around the world. Today, we're going to showcase to you the Trimos portable 3D measuring arms. These are 6-axis and 7-axis arms. I have here with me a Trimos A6. This is a 7-axis arm which is capable of taking measurements in two methods. One is using probing techniques, and two, it's also capable of having a laser scanner mounted at the end for reverse engineering purposes. What's so special about Trimos 3D arms? Number one, they are they offer you benchmark accuracies. Take the Trimos arms, lay out their catalogs side by side with any other competitor, recognized competitors' arms, and you will find that size to size, Trimos arms offer you slightly tighter accuracies than the competition. Take ergonomy. We have arms with electromagnetic brakes. We have carbon fiber casing. Extremely lightweight arms. You can use them with ease for very long arms. You even have not just laptop-based software, but you have also mobile phone-based software, so that the operator can carry the phone with him, and instead of having to walk back to the laptop every time. And what's most special about Trimos 3D arms in India, particularly? Today, if you buy a 3D arm, or today or for the last 10 years in India, if you've purchased a 3D arm, you know that the manufacturer typically asks you to send the arm back to their facility for annual calibration. This means that you lose anywhere from 3 to 4 weeks downtime for calibration purposes. A week to 10 days to ship to them, a week to 2 weeks for calibration, and a week to bring back to your office. Now just imagine you're investing 20 lakhs to 30 lakhs on an expensive, on a very valuable capital asset, and out of 52 weeks of the year, 3 to 4 weeks are gone as planned downtime. What we've done at Trimos is we've developed a complete on-site calibration kit. Yes, Trimos is the metrology company with over 50 engineers across 13 cities in India. Wherever there's a manufacturing base, we've got a local office or at least a local service engineer there. We've got, for our high gauge products, we've got huge, we've pioneered on-site servicing, on-site calibration for the last 20 to 30 years. And we're now putting the same infrastructure to good use when it comes to calibration and online on-site support of our 3D arms as well. So if you buy a Trimos 3D arm, you're guaranteed on-site calibration every year. We'll bring our calibration kit, which is this tripod you see right here, with the calibration sphere and the relevant gauge block based on the arm length that we have. We'll ship all of these along with certain fixtures to mount the arm. We'll ship them to your site, and our engineer will come in with the laptop, and in front of your eyes, we will execute the calibration. So what is today a lead time of downtime of 3 to 4 weeks is going to be a downtime of hardly 2 to 3 days on your shop floor for calibration. This is a straight value of at least 7 to 8% of the, it's tangible value, additional value of 7 to 8% in terms of utilization of your arm if you do the calculation. So let's take a look at the Trimos 3D arms. It's extremely easy to set up, extremely easy to use. So I'm just going to do a very quick routine. We're going to take a couple of simple measurements. Okay. So here I have, the connections are very simple. You've got a power cable and you've got the communication cable to the laptop. The Trimos arms also come equipped with a battery pack so you don't need the cable. They also come equipped with a Bluetooth board, so you don't need the communication cable as well. So you can use a Trimos 3D arm in a full wireless and portable mode. Powering the arm up. And once I power it up, here I fire my communication software with the arm. So I do a quick reference setting process. And then I'm done with that. Restore the arm back to home position. And that's it, right? Now, to this arm, one of the specialities, let's talk about probing, right? By default, the arm comes with a hard probe. The hard probe casing looks like this. It's a simple hard casing with the probe mounted right in there. But today on the arm, we happen to have, for the purposes of enhanced repeatability, we happen to have a Renishaw LP2 probe head mounted on this arm. So this is a touch trigger probe. So yes, with the arm, you have three varieties of probing. You have the hard probe, you have a mechanical floating probe, or you also have the Renishaw touch trigger probe. This is the LP2 probe head again. For applications where you need enhanced repeatability, go with the Renishaw LP2 probe. So we have this probe head mounted here, and we're going to take a few measurements to show you how easy it is. In terms of software, Trimos, with Trimos arms, we recommend Aberlink and Polyworks. Aberlink is an extremely quick and very easy to use, very cost-effective software. At the higher end, when you need raw measurement power, raw analytical power, and extreme ease of use, Polyworks is among possibly the benchmark software available in the world today. So I've just opened Aberlink over here. I'm going to go create a new inspection. So just for example, I've got a sphere here and a bar, so I'm going to set sphere measurement. Aberlink is also, before I go in there, Aberlink is an extremely easy to use software. As you can see, it's all icon driven layout. It's the basic 2D features. Anybody with a basic understanding of 3D coordinate geometry and 3D measurement is going to find this software a breeze to just open and start using in a jiffy. It's very graphical. You can see your top view, left view, front views over here. As you measure, the renderings get displayed. Dimensioning is a breeze. Reporting is a breeze. You get automatic SPC reports and various other very useful reports, which we'll cover in a separate video. So I'm going to go here, select sphere. Yeah, that's it is. In a separate video, we've also talked about the electromagnetic brake feature. When I move the arm far away, and I'm holding here, there is the potential for the arm to fall. But hey, I have this little red button to help me. When I lock it, I can just focus on the probe, and the arm will never fall. Makes it extremely easy to use. So I'm going to start off by taking a simple sphere measurement here. You see how easy it is to probe. So I've taken 5 points. And selected a sphere. And you can see right here the measured diameter of the sphere 19.997. This is a 20 millimeter sphere. So extremely good accuracy. Just for now measure the gauge block. Set it to plane measurement. As you can see, I've engaged the electromagnetic brake, so I can now record, I can now take my measurements without any worry about this arm falling over. So that's my first plane. There it is. I'll measure my second plane. Lock my electromagnetic brake for easy measurement. So as you can see, the gauge block length, it's a 700 millimeter gauge block, and I've got 699.993. So that's how easy it is to measure on the 3D arm. You get a combination of extreme accuracy and extreme ease of use, and superlative service and post-sales support. Thank you very much.